All right, simplifying radical expressions using division follows the same rule that it did when we were simplifying square roots. We'll do a second video about rationalizing the denominator after this one. But first, the nth root of a divided by the nth root of b is equal to the nth root of a over b. If you can simplify a fraction and then take the root of that, it might be easier. Sometimes you're given to it as one fraction and you need to separate it into the separate pieces. We'll approach that maybe in a couple different ways. But for the most part, for these examples, we're going to start with this. We're going to work them that way. So for our first, we've got the cube root of 56 divided by the cube root of 7. Neither one of these are perfect cubes. If we remember our list of perfect cubes, 56 is not on there and 7 is not on there. However, if we combine these as the cube root of 56 divided by 7, we know that we end up with the cube root of 8. The cube root of 8, of course, is 2. Sometimes we have a funky look at an expression, and it might be a little bit difficult to manage, but we find out through some simple acts that we end up with a very rational response. Another way to do this same exercise is to separate this out using the multiplication property we had in the previous video. So you could rewrite that, the cube root of 56 over the cube root of 7, as the cube root of 8 times the cube root of 7 over the cube root of 7. All right, just breaking down the cube root of 56 there into its perfect cube factor and the part that's irrational, the part that's remaining. Well, these end up multiplying out as a factor of 1. The cube root of 7 over the cube root of 7 is just equal to 1, so those cancel, as our elementary school teacher said. We still end up with the cube root of 8, and we still end up with 2. Either approach takes just as long. You can decide which one requires more brain power, which one is easier. It may just depend on the numbers. It may just depend on the situation. For our second example, we've got some variables. Oh no, how are we going to handle this? It's algebra, Mr. Hibbett. I think that we can do this. The cube root of 30y to the fourth divided by the cube root of 16y. Let's go ahead and try to put these together as one giant fraction here under the radical. All right? This fraction that's under the radical can be simplified. All right? This is 15 times 2, this is 8 times 2. So we can simplify that as the cube root of 15 over 8. All right, and for our variables, y to the fourth divided by y will give us a y cubed as our numerator. All right, well, that's not really any better. When we're when we're simplifying a radical expression, we need to make sure that we have no perfect powers with relation to the index, so no perfect cubes, and no fractions or under the radical, and also no radicals in the denominator of a fraction. So we are actually going to have to take this and split it back up from a single fraction under a radical to a fraction of 2 radicals. So watch how we do this. This will end up as the cube root of 15y cubed and the cube root of 8. Now we know what this is because we just did that in the previous exercise. But in my numerator, I've got the cube root of 15, which I can't do. But I've got the cube root of y, which I can do. So I'm going to pull that to the outside. The cube root of y cubed is y. The cube root of 8 is 2. So this is our final simplified form for this expression. The cube root of 30y to the fourth divided by the cube root of 16y. For our last exercise, things get a little complicated. So we've got the fourth root of 48x squared y over the fourth root of 3y to the fifth. Yikes, this is getting a little dicey. So let's go ahead and see how this would pan out if we were to put this together as one gigantic, mega crazy fraction under the radical. 48x squared y over 3y to the fifth. Here we've got a little bit of algebra 1 happening to simplify this fraction. All right, just ignore the fourth root for now and look at simplifying this right here. If we do that, this will give us the fourth root of 16x squared over y to the fourth. All right, the fourth root of 16x squared over y to the fourth. Well, let's go ahead and see how that breaks down. We're going to do the same thing we did here where we took a single radical of a fraction, and we wrote it into as a fraction of 2 radicals. Let's go ahead and break this guy down. The fourth root of 16, the fourth root of x squared, and the fourth root of y to the fourth. So I broke that down into numerator and denominator. In fact, I took the numerator and I split that apart because this is a perfect fourth root. So we're going to go ahead and handle that as 2 times the fourth root of x squared. We'll know how to simplify that in a couple sections, but we're just going to leave it as is for now. And then the fourth root of y to the fourth. The fourth root of y to the fourth is just y. We're going to leave this like so for now. In subsequent sections, we're going to find out that we can actually simplify the fourth root of x squared. Again, we're always assuming that our variables are positive, that these are real numbers, that these exist, and this is the routine that you go through for simplifying these radical expressions using division.